So this is the fifth part now of chapter 10. And basically we got to look at the estimation error. Okay, we made an estimate of the return. So now we have to determine how much error did we make because we used past returns, right? We're using past numbers to predict the future, and there's going to be some error associated with that, right? So there's a thing called the standard error, and the standard error is normally a 95% confidence interval. So we're going to use that to basically give us a measure of the degree of the estimation error, okay? And let me show you how easy it is to do that. So here's the standard error. Let me highlight. This is the standard error of the estimation of the expected return, right? Remember, we estimated the expected return, and there's going to be some standard error built into that, right? So how do you get the average of the independent, the standard deviation? You take the standard deviation of the individual risk, okay, and you divide that by the number of observations, right? Okay, so we calculated the standard deviation previously, right? And what we're looking for here is the 95% confidence interval, okay? So the 95% confidence interval, which I should highlight that. That's what we're ultimately looking for. That's what we're ultimately looking for. How much confidence do we have in our numbers? And the historical average return is plus or minus 2 times the standard error. Okay, so that gives us our historical average return. So for the S&P 500, the historical average return, and basically we would take that plus or minus 2 times the standard deviation over the number of observations here. Okay, and we would end up getting basically 12 plus or minus 4.1%, or the range of our returns. This is the range of our returns. It's going to be 7.9 if I subtract 4.1, and it's going to be, if I add 4.1, it's going to be 16.1. Okay, so this we calculated before, right? 12.0. And let's go back and look, 12.0, and let's look for 19.8. Here's the 19.8. Here's the standard deviation, right? Let me go back here. See that right here? 19.8, the standard deviation, right? Let me see what the historical average return was. Let's look. We might as well look, right? I gotta find it, I guess. Here it is. So here's this S&P 500 average return. So we have those two numbers, and all we do is take those two numbers, right? And let me go back. Let me go up here where we were. And we plug those two numbers into here, right? And plus or minus 2 times that, and it gives us our range of returns. That so it gives us the 95% confidence interval, okay, or this range right here. So as an example here, as another example, so using the returns for the S&P from 12-year period, 2005 to 2017, what is the 95% confidence interval you would estimate for the S&P 500's expected return? So we calculated the average return for the S&P during that period, right, of 10%. You can go back and look at that data. And here was the volatility. So the standard error of our estimate of the expected return then is going to be 17 divided by 13, right? What was it, 13 years, I guess? 13 years, right? Not 12. I think I said 12. And the that's 4.7, and the 95% confidence interval is going to be 10 plus or minus 2 times 4.7, which is what we calculated here, right? So it goes from 0.6 to 19.4. So as this example shows, with only a few years of data, we cannot reliably estimate expected returns for stocks, right? So you need a lot more years, right? So, you know, that's the problem there. All right, here's another example, and this one is for Microsoft, again, for a couple of years, and I guess they have it over, what, 10 years? And here was the standard deviation, here was the expected return. So you notice it's 16.1 right here, plus or minus 19.1. So the range goes from -3 to 35.3. Okay, so the returns of larger portfolios, right? So the difference between the average return for an investment and the average return for T-bills is called the excess returns, right? T-bills is the risk-free rate of return. So the average return on anything else and T-bills is the excess return. Okay, so that's your excess return. And you can see here, here's the volatility for small stocks. S&P, I think we saw this before. We looked at this before. And the excess return, this is above and beyond the T-bill rate. So we take the T-bill rate out here. What we're doing is subtracting the T-bill rate from everything here. And this is the excess in lieu of a risk-free rate of return, okay? So, you know, I hope you're clear on that. Just subtract whatever we calculate for the Treasury bill. So here is the historic volatility. Here's volatility plotted, and here's historical average returns. And you can clearly see that small stocks have the larger return, but they also have what else? Look right here, the larger volatility, right? And look, small return for the T-bill, small volatility, and it almost falls along a straight line here, right? So you can kind of see that. So you can see how that all plays out. All right, so the question is there a positive relationship? Is there some kind of equation between volatility and average returns for individual stocks? So basically there really is none, right? And they just simply say that larger stocks tend to have lower volatility than smaller stocks, and all stocks tend to have higher risk and lower returns by themselves than large portfolios, because you're diversifying out. So these are kind of important statements, right? So this statement here is important, right? All stocks by themselves tend to have higher risk and lower returns than larger portfolios, you know, because you're diversified out. All right, so, and you can see here how this curve, there's really no correspondence here, right? Between stocks, you know, basically 1 to 50, basically 51 to 400, and 401 to 500, right? So you'll notice that there's a lot of stocks here that are got more volatility here, right? But there's no clear relationship here. There's really no clear relationship. So these are the individual stocks, right? Alrighty. So I'll pick up part 6 later on.